you want to do, let's not do that yet. Y equals log base A of x. I want to take the derivative of that function right there. Okay, so how do we do it? I tell you right away, I do not want to use a limit on it. But I can use some algebra. Do you remember the change of base formula? No, the x doesn't come out in front because it's not an exponent, although that's going to be a very handy rule in just a little bit. Okay? Do you remember the change of base formula? Yeah, but we don't want to use log base 10 because that converts us back to this. What's a log that we already know the derivative of? ln, natural log. Yep. So, in general, this is how the, change of base formula works. If I have log base A of B, okay, I can convert this to any base that I want to. The base that I'm going to choose is natural log, okay? So, it's the natural log of B over the natural log of A, using any base that I want, okay? So I could actually do log base C of B over log base C of A. It doesn't matter, okay? And this is what we use to approximate logs with our older fashioned calculators that only do common logs and natural logs. Now that the new calculators that have TI has gone in and allowed you the ability to change the base. So you can actually calculate log base 3 of 7 without having to use this formula. But this formula was in handy years ago when calculators only did ln and base 10. Okay, so now over here, I can actually rewrite this function as what? The natural log of x over the natural log of a. And a is just a real number, right? It's my base of my logarithm. Maybe it's log base 2, maybe it's log base 2/3. Doesn't matter. That a is just some real number, which means that this is really the same thing as 1 over the natural log of a times the natural log of x. This is a constant. And if I want to take its derivative, 0. Okay? But since it's multiplied by a function of x, I can now find y prime using this line. Okay? What happens when you've got some constant attached to your function? When you do the derivative, where does it end up? Well, it just hangs around. Okay? You think of that as a 7 times the natural log of x. Now, what's the derivative for natural log of x? 1 over x. So what's the derivative for log base a of x? This is how we write it. We write it as 1 over x times the natural log of a. Okay, and again, I won't ever ask you to prove this, but I just want you to know that I don't pull these out of a hat. Okay? They didn't just make these up because they looked good. There actually is math behind it to support that this really is the derivative, that it truly does represent the slope of any tangent line. Okay? They just didn't come up with something out of thin air. So we're going to use everybody before us, all their hard work, and we kind of briefly show it to you, and then we say, there it is. Now here's the rule. Let's just use the rule. Okay. So, find y prime if y is log base 21 of x. Just to show you how this rule works. What's my derivative? 1 over XLN 21. Done. That easy. Okay. What about y equals 5 log base 3 of the sine of 2x?
1 over the sine of 2x ln of 3.
Close.
Oh, yeah.
5.
That's right, too.
Okay, so y prime is what happens to the constant in front of any function of x. Just stays. Now, because it's a log, okay, the log is always 1 over something. Now, because it's chain rule, this is what's representing my x. So I have 5 over the sine of 2x times the natural log of 3. Okay, am I done? No, what do I have to do now? Times the cosine of 2x, where did that come from, Greg? Derivative of sine of 2x, which means that you still aren't done yet. What's left? Times 2. That's the derivative of the 2x inside. It was a function within a function within a function. Okay? Chain rule applies to logs. It applies to every function that we've dealt with before. Product rule applies to all of these. Quotient rule applies to all of them. Nothing new, other than you now have essentially 3 new functions to remember. ln, a to the x, and log base a of x. Okay? So now the fun ones. Look at this thing. Y equals the natural log of the square root of x plus 1 times cosine of x over 2x minus 1. That is it. This function is not nice in any way, shape, or form. What would it take if you were going to just differentiate this? What would it require? Chain rule, quotient rule, product rule, trig differentiation, natural log differentiation, polynomials. This is kind of a hodgepodge of everything put together. Would you want to differentiate it?
No,
Is there an easier way to do it?
I hope so. Come to class the next day and ask you.
That would work too. On this one, what are we taking the log of? Square root of a whole bunch of stuff, okay? Do you remember your properties of logs? No? So let's go through. There's 3 of them, okay? If I have log base A of a product, what can I do?
Oh.
Divide log.
Split them apart how?
Yeah.
Logs are nothing more than exponents, right? They actually, a logarithm's answer, the result of a logarithm is the exponent. And with exponents, if I'm multiplying, I can add their exponents. So with logarithms, they kind of have this same rule. If I'm taking the log of a product, I can actually break that thing apart into the logs, the sum of the logs of the factors within the original argument of that log. Okay? So now what about this one? Log base A of a fraction. Subtract them. There you go. Which one from which locus subtraction matters?
Top to bottom.
Top minus the bottom. So log base A of X minus log base A of Y. Okay? One more. Anybody remember what the last one is? Log base A of
Exponent.
X to some exponent called P, because I couldn't think of anything else. What happens, Brandon? Multiply it. The P, exponents get to jump logarithms, okay? As long as the exponent is on the argument, okay? This becomes P log base A of X. So there's your three properties of logs. Can this help me to take the derivative of this function in a much easier fashion? If so, how? First off, what's a root? It's a half power. So I can rewrite this as the natural log of this stuff off of the half power, right? But what can I do with a half power? Put it out in front of my logarithm. So this is now 1/2 the natural log of that stuff. Okay, so I've gotten rid of one chain rule. Now what can I do? Take the natural log of the top two? Okay, they would become a what? Again, Ryan. What would it become? So, I split apart it now, what would it look like? 1/2. Perfect. We got rid of product, quotients. We got rid of almost all the chain rules. The chain rules are now not a function within a function within a function. It's basically a function, just one chain rule for each one of these terms. And now that is so much easier to differentiate. How would you take the derivative of this thing? So now this is exactly the same thing. It's still y, just in a different form. What's my derivative?